about the more times you compound the interest, the more money you're going to get. Okay? So if I compound it an infinite amount of times, am I going to get like an infinite amount of money? Is that something that's going to happen? Or is there some sort of limit? So what we're going to do to kind of investigate this and see, it says suppose you have $1 to invest for 1 year, and that account earns 100% interest. Okay, so it's a lot of interest. We can choose the compounding frequency, and we know the more frequent compounding means the more money accumulated. So if we choose an infinite number of compounding each year, constantly being compounded or continuously compounded, how much do you think we'll have at the end of the year? So in this case, again, we're starting with $1, so our P is 1. Our rate is 100%. So if I move that decimal 2 to the left, I get 1. That's our rate. So as we go and do this problem, A equals our principal is 1, 1 plus our rate is 1, and now we're going to just pick some really large compounding numbers. So let's just say we compound it 1,000 times in a year. Let's see what happens with that. And that would be in the exponent 1,000 times 1 because we're keeping it in for 1 year. What happens if we compound it 1,000,000 times? We'll do 100,000 times. Let's do 100,000 first. And then what happens if we do it 1,000,000,000 times in 1 year? A lot of zeros. And the exponent and running out of room there. All right, so these two tables here, you guys do the 1,000 times. Type that 1,000 in your copy, see what you get. Chase, your group, Frank, in the middle, and Emily, your group, type in the million, see what you get. And then the 3 rows on this, type in the billion one and see what you get.
The billions. Thanks. That's so mean.
All right, so Gavin, I heard you say $2.72. So what is the whole? Do you still have the whole decimal up there?
271.2.71692393.
All right, we'll stop there with 5 decimal places. Okay, so we see how that was our decimal. We rounded to $2.72. Perfect. All right, someone who did the million.
2.71828.
2.71828.
Yeah.
And again, that's going to round to $2.72, right? But if you notice, it's a little bit higher, but not much. Okay. But still, in terms of money, it's still going to round to $2.72. And the billion, what'd you get?
2.71828.
I think this one's 6 here. I got a 6 for this one. But again, it's still going to round to $2.72. So if you compound it an infinite amount of times, you're going to get infinite amount of money. No. Okay. There is like a limit to this. Okay. And this limit is this letter E. I don't know if you, depending on what class you took before, there is this letter E we're going to use in this formula. So if you go to your calculator, if you look above this ln here next to the 4, there's this e to the x. If we press second ln, we see this e in our calculator, and if we press a 1 there, e to the first, look at that, 2.71828. That's those numbers we were just getting, right? Okay, so that means for what we call continuous compound, okay, if it's continually compounded all the time, we're going to use this formula that says A equals P, so P still stands for principal, but instead of having those other parentheses with like the 1 plus or the 1 minus or 1 plus and then the fraction, we're just using this E here. And then in the exponent is still the R and the T. So a lot of times you hear this as PERT. PERT, yep, A equals P e to the RT. Again, your rate is still going to be a decimal, okay? So if we look at number 9, it says we have $800 to invest in an account of 6% interest rate, but the key thing is that it's compounded continuously. The fact that it says compounded continuously means we're not going to use that other formula. We're going to use this PERT formula. And then it says we're not going to make withdrawals or additional deposits, and we're keeping it in for 20 years. So because it says continuous, we're using PERT. A is going to be that final balance. P represents our principal, which is 800. E is the button on our calculator. Again, a 6% interest rate means we move that decimal 2 to the left. So that'd be 0.06 in our exponent. And the number T is always number of years. So we're keeping it in for 20 years here. So now it just becomes plugging into your calculator. 800 second ln gets you the E, and then in our exponent, we need 0.06 times 20. We should end up with $2,656.09. All right, we'll do one other example. Let's find the balance of the account after 5 years. If we have $1,200 is initially invested, interest rate of 12.5%, and it is compounded continuously. And that continuous is super important because it's telling us to use the PERT, not the other compound interest problem. If it says compounded quarterly or compounded monthly, that's when we use the formula that we had before. When it says continuous, we're using the PERT. So we have A equals 1,200, the P of PERT, E is the button on our calculator, 12.5%, move that decimal twice, we get 0.125, and we're keeping it in for 5 years. Get $2,241.90. Again, this 5, we change the 9 to a 0 and move that 8 up to a 9.